Well, the Stephen Hawking Center came about because Stephen Hawking flew in a microgravity flight in Florida. And at the time, we approached him and said, we're doing a lot of research on microgravity. And Stephen had made statements about how the reason he did this flight was to get the public interested in space because he believes space is our future. And without space, we don't have a future. So we approached him and said, could we create a microgravity center in your name in order to continue developing this vision? And he said yes. So we're now standing it up and we're getting ready to find ways to communicate to the public and to educate the public about the importance of space, to continue creating a pipeline of researchers and engineers and technologists and artists and communicators who will help the whole world be involved in space, because we really believe our future is in space.
My name is Dr. Addie Dove, and I am an associate professor in the physics department. So a lot of our research is looking at different things that happen in microgravity. So we need a microgravity environment in order to understand a lot of the forces of things that happen on planets in space or spacecraft in space. And so things like, how do dust grains move around on the moon or on asteroids, these really interesting planetary surfaces that have very low gravity. What is microgravity? Microgravity is sort of what we often think of as like the lack of gravity. So if you think of astronauts floating in space, or you think of the surface of an asteroid, there's really, really low gravity there. It's not actually that gravity isn't there, it's just that like the forces you feel are very, very small. And so that's microgravity. So like micro is actually a term that's very small, right? We use that in other things also. And gravity. So on Earth, we have one gravity. In different places in space, we have very, very low gravity, so it's microgravity. What is the drop tower? The drop tower is a way to get a very short duration of microgravity. So there's actually drop towers around the country and around the world. The basic idea is like a falling elevator in an elevator shaft, right? So you just always think of that. When you cut the cord of the elevator, it just drops. It's in free fall. That's the idea of a drop tower, is that you have something where you can drop a thing in free fall, and for whatever brief period of time while it's dropping, you get a reduced gravity environment. One of the big aspects of our research is understanding granular materials or particles that are like what's on the surfaces of the moon and asteroids. So those, it's called regolith generally. It's the broken up bits of rock on the surfaces of planets. And here at UCF, through the Exolith lab, we developed simulants that we can use that are compositionally similar, and a lot of times they have similar physical properties, so like the particle sizes and things that reproduce those planetary surfaces. So we try to use those simulants of all different types to do our experiments to understand what effect those have on our results. There's sort of twofold goals of our research. One is the really science, like actually understand the physics of these really complicated surfaces and these interesting things that happen in low gravity environments. And the other side of it is using that knowledge to drive forward exploration.
There's really so much that you can do in microgravity. I guess for me personally, I get excited about the prospects of moving human civilization beyond the Earth. And so to do that, we have to develop technologies that can operate and reduce gravity. So I think developing those technologies is the most exciting part for me personally.